Hello everybody, just a quick update to tell you that we launched the production of the kits for the Indiegogo campaign. You received an email if you paid for a battery so that we can gather your email and also your delivery address. And on the rest of this video, we are going to show you some tests that we've done on the production batch, the first 100 that we received. They are going to be used soon, I think next week, by Pony. They already ordered the next batch, so it's a good news for the business and for the whole project. Speak soon.
Hey everyone, so since the last update where we produced the first batch, we've been hard at work to test the new batteries, mechanical tests, electronics tests, water tests, fireproof tests, everything to make sure that the battery are high quality. And meanwhile, they are being tested by one of our partners in France. And we're going to run you through an overview of those tests and the results.
And today is the testing of the vibration of the battery. We want to see if there is any disconnection. As soon as a cell disconnects, I see that the voltage drops. So I'm measuring, let me show you. So here is the setup. I'm pulling a little bit of current, so not yet, but I will turn it on just after, from the battery, which is here. And here is the vibration pot. And here I'm monitoring any disconnection. So if any disconnection arises, I will have this that turns red. So now I'm gonna start my profile. So as you see, we start slowly. Everything's fine. Like this?
Yeah.
Okay. Like this.
We did a test to check the power consumption of the BMS in different modes when sleeping and when active with a very precise logger and found no issues. So in addition to the power consumption test, we also had the different companies review all our schematics of the BMS and they found no issues. So we were quite confident that our electronics is very high quality now. So it's not very clear from this picture, but basically we immersed the battery below 20 centimeter of water and we made sure that there was no winter ingress. And then once we removed the battery, after the test was complete, we tested physically that there was no water, and then we looked at the humidity sensor. We showed no more than a 5% deviation from standard readings on dry batteries. So for this test, we sprayed salted water, approximately 10% of salt per weight, on the BMS, which was non-tropicalized, so non-protected. So that's really the worst case scenario. And we wanted to show that there's no big spark that could cause a thermal runaway.
So before we start, what we can see is that the BMS is maximum at 26 degrees near the power supply. Let's see what happens when we put salt spray. So there is a hot point at one. So we can see that here the temperature rose at 50. And there are small shorts. Okay, that's normal. High power. What we don't want to see is a big, huge spark. So in terms of power, we are putting like 7 watts, and you can 10 watts inside the BMS.
since we made some modifications in the casing and the vents, we did again the fireproof test. So we drilled a nail through the battery to force fire, and we saw that only fumes escape and the fire is contained for at least 10 minutes